welcome to Teach Crest International. I'm your host, Ruth Karibo. So today, we're going to look at intrazonal soils. So intrazonal soils involves halomorphic soils. We have calcimorphic soils, we have andasols, and we have hydromorphic soils. Let's start by looking at andasols. Andasols, also known as volcanic soils, are soils that are formed from recent volcanoes, and they have the following characteristic. One, they are dark brown with high silt content. You can see here the dark brown, and because of that silt content, you can be able to see they're able to retain much of the roots. It's easy to establish the roots deeply. At the same time, they are hydroporous despite having a solid structure, and that allows them to be well aerated and to be well drained, so there is soil permeability, making it suitable for growing of crops such as wheat, tea, and coffee. And remember, volcanic soils are found in most highlands, like the Kisi Highlands. It could be found in Chulu. We have Marsabit, Taita Hills, we have Busia, Nyamira, Embu Meru, Central Region, Chirangani. We have Mount Elgon. Like this one is Mount Elgon, which is in the boundary between Kenya and Uganda, and coffee is the main crop grown there. Mainly because of the topographical reasons, like the height, which provides cool conditions, and as well as the fact that, so you can see they can get to support variety of crops because they are fertile. Remember, once volcanicity has happened, there is throwing of that volcanic ash, which could be rich in nutrients. And most crops require nutrient-dense soils, so a variety of crops can be grown, including wheat. Another thing, they're light. They're less dense. Because of that low density, it means even cultivation of the soils becomes easy. There's no formation of hard pans, so plowing is really easy because they're light. Another thing to note is that they have high organic matter. Because of that high organic matter, it means even it helps to compact the soil together, so it has what we can call a high water retention power, despite being solid. So because of that, they're able to store water, and because of that water holding capacity, it enables them to be drought resistant throughout the year. So another thing is that they allow free drainage. They're well aerated, like I had already said, and they're found in areas like Ethiopia, where we grow coffee. You can talk about Asia within Philippines and Japan. We also have Central America having andasols. So you can see something like coffee can really grow in such areas. Another type of soils that we have under intrazonal are calcimorphic, from the word calcium. So these ones have been formed due to a process known as calcification. So basically, calcification is a process that limits the leaching of calcium. So in this case, you find calcium gets redeposited within the same horizon. There's no vertical movement downwards or upwards. So that redeposition of calcium carbonate compounds leads to formation of calcimorphic soils. And a good example is the Terra Rosa, which is found in Brazil, as we saw, that enables growth of coffee. Also, we have the red zina or renzina. This is a Polish name to mean soils that are underlain by gray or yellowish calcareous parent material, which is rich in lime. So the renzina is therefore a shallow soil which is rich in humus and lime, and it develops on grass or limestone areas in most cases, so it can also be formed on pozolized soils. In some cases it is referred to as zerondensina, yeah, which is an English or a Russian name for such soils, calcimorphic. So these ones can be traced to areas that are limestone regions, like in Kenya we have the coastal region as well as the northeastern region. So, and someone could ask about the humus. So the humus is due to the grasslands which get to decompose and they form humus within the upper zones of the profile, thus providing humus, or rather the organic matter, which allows productivity of maize and also cotton. And these soils, because they have high ability to absorb water, they get to support crops like cotton that require water. Yeah. A good example is as shown below. You can see it there. So you can see here, you have those soils beneath which are underlain by its grey yellow, as you can see. Looks something like muramish. Yeah. So it's an example of red zina. That's how it looks like. Another type of intrazonal soils, so that we have. Okay, I wanted to show you about the terra rosa also. And before that, get to study this image. You can see behind we have grassland. This is what is providing the humus that is used by the different plants there. You can see it. Yeah. You can see the grasslands. They will get to decompose, and because they are in regions that receive less rainfall, after some time they will decompose, yeah, to form humus. So that's why you can see on top they are a bit dark, to show that humus. Yeah, this is what we call the black cotton soils. Yeah. Yeah, and they're common in the Russian steppes like here. Then we got the terra rosa. You can see the terra rosa soils. And this is the closer. You can see it cut out. Yeah. Because of the humus and lime, so it can be able to support a number of crops. Look at the red terra rosa soils. Ooh, beautiful. Actually, people can use them for landscaping purposes, and it's awesome. Then we have halomorphic or halomorphic soils from the word halogen. So they are made up of the group 7 elements, such as chlorine, which will react with sodium to form sodium chloride, and that's why you see some of the soils will be saline. We can have iodine, bromine, fluorine, etc. reacting to form the various compounds. So I want to see how halomorphic soils are in terms of their characteristics. So because the group 7 elements get to react with other compounds to form salts, we can see the halomorphic soils are formed by the process of solubilization, and because some of the salts are soluble, they can get to be leached. If they move from one layer to the other, they will form what we call solonce salts. But if they remain on the surface, they will be known as solonchak. Solonchak, S-O-L-O-N-C-H-A-K, soils. So they are infertile, and at the same time they are poorly drained because they don't have humus, and as such they don't support a variety of crops in such areas. So that's why you'll see pastoralism being conducted in such areas, and for the little grassland that will grow, that will get to support uh, tourism in terms of the wildlife that will grow there, the fauna and flora that will flourish, and people go there. That's why we'll have something like Amboseli National Park in Kenya. So due to the semi-arid and arid conditions, the rate of evaporation is high. So water is lost and what remains behind are the soils deposits. The soil deposits are responsible for the light color of the halomorphic soils, right? The other type of soils that we have are known as hydromorphic soils. Hydro means water, morphic means structure, so it means hydromorphic soils are soils which are saturated with water within their structure. They're waterlogged, and that's why you'll see their color will be gray or purplish. Yeah, you understand? And once, because of that water saturation, it means in most cases they have a high water retention capacity despite being poorly drained, and that makes it them to be difficult soils in terms of cultivation. It becomes very expensive because you wanna reclaim that land. You have to do a lot to ensure such areas become better. So they are common in wetland areas, and these include meadows, we have marshes, we have swamps, and plains. So let's begin with the planosols. These are found on flat old land surfaces. In Kisii we call it ebirugo. Yeah. So you'll tend to see an area like Seronga, Esani in Kisii. They have planosols. Yeah. We also have hydromorphic soils, the ones which are found in water-prone areas, like this one. Oh! Hiya! I'm almost fallen down. Here is some place. You can see it's grey in color because it's waterlogged. I've actually fallen down. It was funny. Yeah, you can see the children picking some what. These are hydromorphic soils. You can see part of it is green. We have the, I'm still oily. Actually, I fell down. This is so funny. So they are green color. You can see the ones because of siltation. It's right at the center. So we have the marshes, which are wetlands frequently or continually inundated with water. So they contain emergent vegetation adapted to saturated soils. In short, they have hydrophytes. So marshes include both tidal and non-tidal. Then we have swamps. These are wetlands dominated by woody plants. So something like papyrus. Saturated soils during the growing season and standing water during other times of the year. And you can see the bogs. These are wetlands containing spongy pits, deposits, acidic waters, low nutrient levels, and a floor covered by a thick sphagnum moss. This type of wetlands receive most of its water from precipitation. Then we have fens, so similar but different to bogs. Fens are peat-forming wetlands that receive nutrients from drainage. They're less acidic and have higher nutrient levels. Why? Because of siltation. So materials are being carried from other areas. So that's a close-up view on how they look. Then we have Andasols. These are found in, they are poorly drained but better than peat. Then we have soils. These are the ones which are found on old land surfaces and they are imperfectly drained. So they are often waterlogged. In case we call them, I guess, somewhere here. Like this one was Lorraine swamp spinach that was flowing. You can see the soil, it's gray. Then here we have peat moss, which is usually used as a potting mix for, and it can also be used as an hydroponic substrate. So you can see people, they go and harvest that peat and they get to sell. They can mix with cocoa. Yeah. There you go. These are where some of the hydromorphic soils are likely to form. Like this is a meadow. You can see the flowers there. They indicate that the soils will be having meadow soils. So there you go. So that is it. You can see such soils. This one, the salt marshes, classified as hydromorphic soils, in the category of intrazonal order soils. Until next time, I've been your host Ruth Kerubo. Please subscribe, share, and like, and do not forget to comment below on anything concerning this topic or what you'd love me to tackle. Bye. Mwah.